All right, how's it going, AP Stats class? This video, I'm going to go over how to find and interpret a standardized score, also known as a z-score, of an individual value within a distribution of data. All right, so as an example, we have the number of points students earned on a Chapter 2 quiz, and the data is provided to us in a stem and leaf plot. Okay, the key says a 5-0 is 50 points. Okay. All right, so the standardized score, in order to calculate this, you need to know the mean and standard deviation of the distribution. So it's not surprising that the first thing they ask us to do is to calculate the mean and the standard deviation. Okay. All right, so let me grab a pencil. All right, so we know that the mean is going to be the sum of all the scores. So we'll just go in order 0 plus 1 plus 2 plus so on, all the way to 50. And then we're going to divide by the number of scores there are. I don't think it tells us, so we have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Let me just write that somewhere. N equals 23. Okay. All right. So I haven't shown you guys yet, but in your calculator, if you have a pretty small data set like this, you can actually enter the data set into your calculator and it will calculate all the summary statistics for us. Okay. So you're going to hit the stat button and then under the edit menu, choose edit. Okay. And this brings up like a sort of spreadsheet looking screen. Okay. All right, so I'm going to enter the scores in list 1. So 0, 1, 2, 12, 12, 14, 18, 21, 21, 23, 24, 25, 29, 29, 30, 30, 30, 33, 36, 44, 45, 47, and the last value is 50. Okay. All right, and then from here, I could press stat calc 1 var stats. Okay. And I just need it to say list 1, that's the column I put the data in. For frequency list, we want that to be cleared. We don't want anything there. And then hit calculate. Okay. All right, so it's telling me that the mean score for this class was about 25 points. So say approximately 25. Let's go 25.04. I'll go 2 decimal places. Okay. All right, now to calculate the standard deviation, right, that's where we have to take each value, subtract the mean, square it, and then just repeat that process. All right, so 50 minus 2504 squared, right? So we're adding up all these square deviations, okay? And then we're going to divide by n minus 1. Okay, so 23 minus 1. Okay, and then we also have to take the square root. Okay, now obviously I'm not going to perform that calculation, but right, we have here under the 1 var stats report the standard deviation. They call it SX. Okay, so it's 14.20. All right, so now we have the mean and the standard deviation. All right, Elise earned a 45. Okay, calculate and interpret her standardized quiz score. Okay. So the z-score is going to be the data value minus the mean divided by the standard deviation. Okay. And what this is calculating is not how many raw points Elise is from the mean, but how many standard deviations she is from the mean. Okay. Now the reason why we don't want to focus on raw points is because, well, let's say she's 5 points above the mean. Okay, well, that could be good that could be bad. Well, it can't be bad, but it could be good or it could be really good, right? If there's a lot of spread in the scores, then 5 points doesn't mean a whole lot, right? But if the scores show very little variation, then 5 points would be a big difference, okay? So that's why we don't just do the value minus the mean, but we also have to incorporate, how spread out are the scores? How much variation is there? Because a 5 point difference might mean a lot, or it might not mean very much. Okay, so she got a 45. The mean was 25.04, and the standard deviation was 14.20. All right. So we'll do 45 minus 25.04. Okay, so she's about 20 points above the mean. Okay, and then we'll divide by 14.20. So in standard deviations, she's about 1.41 standard deviations above the mean. Okay. So we'll write that. Elise scored 1.41 standard deviations above the mean. Okay. So one of the keywords here is the word above, right? Because the z-score came out as positive, we know that her score is higher than the mean, okay? Had this come out as negative, which we'll actually see in part 3, right, then the interpretation is going to be just slightly different. All right, Carl earned a 2. Okay, calculate and interpret his standardized quiz score. Okay. So his z-score is his value minus the mean divided by the standard deviation. Okay, so 2 minus 25.04. Okay, so Carl scored about 23 points below the mean, but in terms of standard deviations, that's about 1.6 below the mean. Negative 1.62. Okay, so Carl scored 1.62 standard deviations below the mean. Okay, so you'll notice that even though the calculation came out negative, in my interpretation, I don't include the negative sign. Rather, I just use the word below, right? That's my interpretation of the negative sign, is that his score is below the mean. All right, so one of the great benefits here with the z-score is it allows us to compare values that come from different distributions. Okay. So in question 4, we see that the scores for the next quiz had an entirely different mean and a different standard deviation. Okay. Elise scored a 47 on this quiz, right? On which quiz did she perform better relative to the rest of the class? So at first glance, someone might say, oh, 47 on this quiz, she had a 45 on the previous quiz. So, well, 47 is higher. So maybe we should just automatically assume that she did better on the second quiz. Okay. But we have not taken into account what the mean or the average score was for each quiz, right? One quiz may have been harder or easier. And we haven't taken into account how much variation there was in the scores, right? One quiz may have had scores really consistent and clumped together, whereas another quiz may have had scores that were really spread apart and varied. All right, so let's calculate her z-score on this quiz. Okay, so her data value is 47. The mean on this quiz was 32, and the standard deviation was 6.5. Okay, so 47 minus 32. Okay, so she scored 15 points above the mean. But in terms of standard deviations, she was about 2.31 standard deviations above the mean. Okay. So on the second quiz, right, she was more than 2 standard deviations above the mean. Okay. And on the other quiz, she was only 1.4 standard deviations above the mean. Okay. So we would have to conclude now that her performance is better on this quiz because she was higher above the mean, further away in the positive direction above the mean. Okay. All right. So Elise did better on this quiz since she was further away from the mean. Right, the simple explanation is her quiz had a higher z-score here, right? 2.3 is larger than 1.4. She had a higher z-score. Okay.